So this is a video for part 3 of the second algebra unit covering inequalities. We had stopped with C, we graphed C, so now we want to do D. So I've written the problem on the right hand side of the screen, and this one is a little bit different because we've in the past questions we've looked to see if we needed to simplify the left or the right hand side, and we didn't, and this time we do. There's a parentheses on the left hand side, and we can do the distributive property. So hopefully you'll remember that. That's when, if you can't add the numbers inside the parentheses or subtract them, 8 minus 12x, they're not like terms, you can multiply the number outside of the parentheses by everything, each term inside the parentheses. So 1/2 times 8 is 4, and 1/2 times negative 12x is negative 6x. And then we bring down our greater than or equal to sign, our x, and our minus 10. Okay, so now we want to check again to see if anything can be simplified. On the left, 4 minus 6x, you can't go any further. X minus 10 on the right, you can't go any further. So now we need to solve for x, except there's an x on each side, so we need to put them, consolidate them on one side. So I can either add 6x to both sides, or I can subtract x on both sides. So you would add 6x on both sides because of the because you're subtracting it, and the opposite would be to add it. Here, this is a positive x subtracting 10, but you wouldn't add the x because it's positive. This is positive, so you would subtract it. Let's do that. Let's subtract the x from both sides, and we get 4. Negative 6x minus x, that's like saying negative 6x minus 1x, and you get negative 7x is greater than or equal to, the x's cancel, negative 10. Now we want the x by itself. So we can get rid of the 4 or the negative 7. And as I told you before, it's usually less complicated to get rid of the constant that's being added or subtracted. So this is a positive 4. So we're going to get rid of it by adding a negative 4 or subtracting a 4, whichever way you want to look at it. And that will leave negative 7x is greater than or equal to, negative 10 and negative 4 is negative 14. Okay, and then we want to undo the multiplication. This is negative 7 times x, so we're going to divide both sides by negative 7. Alright, on the left hand side we get x. On the right hand side, negative 14 divided by negative 7 is 2. But we just divided. Remember our rule right here, if you multiply or divide both sides of an inequality by a negative number, you have to reverse the sign. So instead of greater than, we're now going to change it to less than or equal to 2. Okay, so if we had a 0 here, 1, 2, negative 1, negative 2, okay, 3, 4, 5. We're going to put a closed circle on the 2, and we're going to shade to the left. Okay, so that's all for number 2. Okay, so then right below number 2 it says, when multiplying or dividing by a negative number, the inequality sign, so you can either say that it reverses, or you can say it flips. Okay, number 3 says indicate whether the value of x shown is a solution of a given inequality by answering true or false. So to be a solution, it is a number that when substituted in for the variable, it makes the inequality a true statement. So let's look at the first one. We have 8 minus 3x is greater than 5. So what we're going to do is we're going to replace the x with this 1 over here. And now we're going to do some arithmetic. On the left hand side we have 8 minus 3 times 1 is 3. So you have to use order of operations. That means you do multiplication before you do subtraction. So you don't say 8 minus 3 is 5 times 1 is 5. We do 8 minus, which that actually would end up working here, but that is not the way you're supposed to do it. You're supposed to multiply first. So negative 3 times 1 is negative 3. 8 minus 3 is 5. And then you ask yourself, is 5 greater than 5? No. So it is false. Okay, the next one, 4x minus 7 is less than or equal to 2x plus 1. And instead of an x, we'll replace it with a 4. Because that's what they gave us there. Okay, so 4 times 4 is 16. Bring down minus 7. And your sign. 2 times 4 is 8. Bring down your plus 1. 16 minus 7 is 9. 8 plus 1 is 9. Is 9 less than or equal to 9? Well, it's not less than 9, but it is equal to. So this makes this a true statement. Okay. So you try C and D. Pause the video, try C and D, and then unpause when you want to check your answers. Okay, the next one we substitute in negative 7. When we multiply, we subtract negative 7 plus 6, and we get negative 1. And we multiply, we get negative 6. Negative 6 is not less than negative 9. 6 is less than 9, but negative 6 is greater than negative 9 because they're negatives. So that is a false statement. And when we substitute negative 3/4 into the last one, we get 4 is greater than or equal to 6, which is also false. Okay, so moving on, we have some examples. These are just more practice problems from what we were doing before. So hit the pause button, practice these, and then unpause when you're ready to see what the solutions are. Okay, here's the answers to the first 4. X is greater than 6, open circle, shade to the right. Number 2, x is less than or equal to 21, closed circle, shade to the left. X is less than 5, open circle, shade to the left. And x is greater than or equal to 2, closed circle, shade to the right. Okay, now we're going to look at the next 4. Again, pause, work these, and then unpause when you're ready to see the solution. Okay, taking a look at the next 4. These have decimals, and so I think you're probably okay with the answers, but I want to make sure that you're cool with the graphing. So the first one, x is less than negative 3.8, so it's negative, so we're counting backwards. If you see how they've divvied this up, there's 1, 2, 3, 4 bars in between the negative 3 and negative 4, so each one is 0.2, so this is 3.2, 3.4, 3.6, 3.8, negative. So that's why that's there. Negative 4.5, there was 3 in the middle, so the middle one is halfway, so that was the 4.5. You should be good with negative 9. And then 14.6, again, they counted by 2s, negative 14.2, 0.4, 0.6 is right there. Okay. On to the next 6. Hit pause and try these. Okay. And here are the next 6 answers. Okay. Just hit pause to check them. On to the next ones. Okay, the next section is identifying solutions, and this is the same kind of thing, but I'm going to show you some new types of notation. Okay, so we've dealt with what is called inequality notation, so now I want to show you interval notation. Okay, so let's take something like x is less than 5. Okay. So this is inequality notation. It's the notation where you have an inequality symbol in it. So interval notation is where you don't use this variable here at all, like this x. You don't have any x's at all in this notation. Okay, so when we have x is less than 5. So think about what numbers are less than 5. So just think about the graph. All right, so if this is your 5, open circle, it would be shading everything to the left all the way to, how far does this arrow go? How far is this going? It's going all the way to negative negative infinity. Okay, so basically what you want to do is you want to give the interval x's all the numbers between negative infinity and 5. It's all the numbers between here and here. And that's what you want to write. So interval notation, you just write the leftmost point, comma, the rightmost point. And now this is very important. If it equals that number, if that number is included, you use brackets. If that number is not included, then you use parentheses. So if x is less than 5, it goes all the way from negative infinity to 5, right? So here's the question, is 5 included? Is it included? Well, we had that open circle. There wasn't a line, so it's not included, so we will use parentheses. Is negative infinity included? Well, this arrow keeps going to negative infinity. However, since negative infinity is really just the idea that numbers go on forever and not a number itself, it can't really equal negative infinity. It's just approaching negative infinity, so we will use parentheses for that as well. If you had x is less than or equal to 3, so that graph, here's 3, closed circle, shade to the left, it's all the numbers from negative infinity to 3. So from negative infinity all the way to 3. You can't equal negative infinity, but 3 is included, so you would use brackets there. Okay, so let's look at these examples. We want to write these in interval notation. So this graph would start at -2, closed circle, and then it would shade to the right, and it would go all the way to positive infinity. So the leftmost number is -2, the rightmost number is infinity. -2 is included, bracket, infinity, parenthesis. Here we go. This one's really easy. The leftmost number is 3, rightmost number is 5, comma in between. Neither one of them have the line underneath, so they're not included. Use parentheses. -2 on the left, 7 on the right. Both are included. Use brackets. 5 on the left, 6 on the right. 5 is not included. 6 is included. Now I do want to real quick go over this because this is in the in the homework. So in the homework, instead of using the closed and open circle like I showed you, they actually use the brackets and the parentheses on the graph. So for this one, if you had -2, they would, since instead of doing a closed circle on the 2, they would do a bracket on the 2, and then they would shade to the right. On this one here, here's 3, 4, 5, since neither one are included, they would do parentheses instead of open circles and shade in the middle. Here's -2, 3, -2, 1, 0, 1, 2, 3, 4, 5, 6, 7. Again, these are included, so brackets instead of closed circles, shading in the middle. Here's 5, here's 6. You would do a parenthesis on the 5, a bracket on the 6, shade in the middle. So basically I'm just showing you the graphing is the same kind of thing. It's just instead of open circles you use parentheses, instead of instead of closed circles you use brackets on some of the homework questions. Okay, so we're gonna have to go on to part 4, it looks like.